Good morning or good evening. Today we're going to talk about solving trig equations that look a little different than the other ones that you've been doing, because in these equations you're going to see more than one trig function in one equation. Well, what does that mean? In the past, if you want to flip back to page 4, you can see that starting with example 2, whenever we've tried to solve trig equations, the whole equation has been in terms of cosine. Like here's cosine squared and here's cosine. In example 3, cosine squared and cosine. In example 4, we've got cosecant squared and cosecant. And then over here on page 5, we have a couple of equations, all in terms of cosine, all in terms of tangent, and up here, all in terms of secant. But what we're going to see here is we're going to have, for example, both sine and cosine in one equation. So when I say more than one trig function, we're going to see something like sine of theta and cosine of theta in one equation. So that's, if you remember, we like to let x equal sine of theta or x equal cosine theta, depending on what we have. Well, what we have is something like an x and a y in one equation. And it's really hard to, or it's impossible to solve a single equation if you have two variables. So what we're going to have to do is we're going to have to use identities to reduce the equation to a single function. So a single function means we're only going to have sine or cosine. For example, only sine or only cosine in one single equation when we started out having both sine and cosine in one equation. So how we're going to do this is one of the identities that we're going to use is the one that we learned a while ago called the Pythagorean identity. If you see a sine squared, now this is important that the sine has to be squared or the cosine has to be squared. So if you see sine squared or cosine squared in an equation with the other trig function, what you're going to do is replace them. If you remember, sine squared of any angle plus cosine squared of any angle is equal to 1, no matter what angle you put in there. That's why it's called an identity. So what we're going to do is if we see sine squared in an equation, or we see cosine in an equation, and we've got two trig functions in one equation, we're going to do some replacement. And so what we can do is we can take this sine squared of theta, and we can subtract, or we can take the left-hand side of the equation, sine squared plus cosine squared, and what we can do is we can subtract cosine squared theta from both sides of the equation. So that would cancel out, and what we'd be left with is sine squared theta is actually equal to, this one would drop down, and minus cosine squared of theta. So that would be a substitution that we could make. So we could substitute in for sine squared of theta if we need to. We would substitute in the 1 minus cosine squared. Well, the other thing we can do is if we see a cosine squared in our equation and we have a sine, or just a regular sine of theta in that, what we can do is we can do the same type of substitution, but if we wanted to substitute in for cosine squared, what we could do is we could subtract out sine squared from each side of the equation, and what we would be left with is that the cosine squared of theta is equal to, this one would drop down, 1 minus sine squared of theta. So we could use this to substitute for a cosine squared theta if we need to. And we're going to be doing some examples of that, so you'll see what I mean by that. Oh, here's an example right here. Now look at this equation. We have a cosine of x in here. It could be theta. If you wanted to change this to theta, you could. It doesn't matter what this letter is. I just used x. So if we have a cosine and a sine, we have to do something about that. We have both sine and cosine in one equation. That's like having an x and a y in one equation, and we can't solve for that if you have two variables. You only could have one. So what we have to do is we have to take this cosine squared of theta, because we can substitute in for that. We can't substitute in for a sine of x, but we can substitute in for a cosine squared, and what we are going to do is we're going to use this substitution. And please make sure you see that this 2 drops down in front. This is really important. This 2 coefficient drops down in front there. And the cosine squared of x gets replaced with 1 minus sine squared of x. All right, that's the replacement that we need to make. And then this 3 sine of x is just the same, just keeps dropping down, and everything else just drops down and doesn't change at all. Don't change any of these. The only thing you're going to change is a cosine squared, and do that substitution. So the next thing we're going to do is we have to distribute the 2. So this 2 gets multiplied by the 1, and it gets multiplied by the negative sine squared. So 2 times 1 is 2. 2 times negative sine squared is negative 2 sine squared of x. And then we drop everything down, plus 3 sine of x minus 3 equals 0. And now we have an equation that's similar to the other ones that we've solved, because everything now is in terms of sine. We only have sine of x because we got rid of the cosine of x by this substitution here. So if you wanted to just clean things up a little bit here, we have a 2 and a minus 3. We can combine like terms because it's on the same side of the equal sign. So what we have is this negative, and be careful of this negative when you drop this down. You almost always have a negative out in front of sine squared. So we'll drop this negative 2 sine squared of x. We'll drop down this plus 3 sine of x, and we'll combine like terms. 2 minus 3 is minus 1 equals 0. And we don't like to have a leading coefficient be negative. So what we're going to do is we're going to divide everything by negative 1. That's so we can get a positive leading coefficient instead of a negative. So all the signs change. All signs change. So this becomes a positive 2 sine squared of x. This becomes a negative 3 sine of x. And this becomes a positive 1 equals 0 divided by negative 1 is still 0. And now we have something that looked like what we did yesterday. This is like solving 2x squared minus 3x plus 1. I just write that, I guess, in a pencil. So it's like solving 2x squared minus 3x plus 1 equals 0. Well, what we can do is multiply 2 times 1 and get 2, and the factors of 2 that add up to negative 3 are negative 2 and negative 1. So that factors out to be 2x minus 2 and 2x minus 1, all divided by 2. So those reduce down to x minus 1 times 2x minus 1 equals 0. So x is equal to 1 and x is equal to 1/2. But it's not really x. This is a sine. We let x equal sine of x. So we'll set up our t table here. We have sine of x equaling 1 from this side, and we have sine of x equaling 1/2 from this side. When we look on the unit circle, because if sine is equal to 1 or 0, we have to go on the 4 important points of the unit circle. And where does y equal 1? Up here at 90 degrees. So x is equal to 90 degrees if the sine is equal to 1. And if sine is equal to 1/2, we have a reference angle that's equal to 30 degrees. We have a quadrant 1 answer because sine is positive. Our theta value is 30 degrees. And our quadrant 2 theta value is 180 minus 30, which is 150 degrees. Make sure you know how to get those theta values. That's 180 minus 30 degrees. Over on the other page, what we have is a similar problem. What we have is a sine squared of theta and a cosine of theta, both in the same we have a sine and a cosine both in the same equation. So we're going to make the similar substitution. We're going to get rid of the sine squared of theta. We're going to get them out of there, and we're going to substitute that in with the cosine squared of theta. Well, this one says on your own. So if you would like to shut the video off right now and try this on your own and go through this just like we did the other one, that would probably benefit you very much. Otherwise, you can just watch me do this. So the 4 drops down. Now the sine squared of theta, we're going to make this substitution in 1 minus cosine squared of theta. So 1 minus cosine squared of theta gets substituted in, plus, now we don't change the 4 cosine of theta, equals 5. So then we're going to distribute the 4, and this becomes 4 times 1 minus 4 times cosine squared of theta plus 4 cosine theta is equal to 5. The next thing we're going to do is subtract 5 from each side because it has to be equal to 0. Or if you wanted to call this 4 minus 4x squared plus 4x is equal to 5, you can. But we need to subtract 5 from each side of the equation so this can be equal to 0. You have to have it equal to 0 before you solve these things. 4 minus 5 is negative 1 minus 4 cosine squared theta plus 4 cosine theta equals 0. And the only thing we have to do now is we have to rearrange this. We should probably move this negative 1 over here. Drop the negative down, negative 4 cosine squared theta plus 4 cosine theta minus 1 equals 0. All I did was move it. I moved this negative 1 over. And then you're going to divide everything. You're going to change all the signs because we don't like to have a negative leading coefficient. And this becomes positive 4 cosine squared theta minus 4 cosine theta plus 1 equals 0. And now we have to, so now we're going to factor this. And 4 times 1 is 4, and the factors of 4 that add up to negative 4 are negative 2 and negative 2. So inside parentheses, you can put, let's call this 4x squared minus 4x plus 1. So you can put 4x minus 2 and 4x minus 2 and divide the whole thing out by 4. And 4 is too big, so you have to split 4 up into 2 times 2. So this reduces down to 2x minus 1 times 2x minus 1. And that is equal to 0. So that means x equals 1/2. X equals 1/2 here, and x equals 1/2 here. So x is only equal to 1/2. You only have to write it once. So if x is equal to 1/2, well, what are we talking about? We're talking about cosine of theta. So it's not x, it's cosine of theta is equal to 1/2. And you don't need a t-table on this because you don't have 2 different values of cosine, you just have 1. So we'll have a reference angle. And remember, do second cosine of 1/2 to get a reference angle. So the reference angle is equal to 60 degrees. And cosine is positive in quadrants 1 and 4. So in quadrant 1, the angle is the reference angle, 60 degrees. And in quadrant 4, the angle is 360 minus 60, which is 300 degrees. So on this problem, there are only 2 answers because you only have 1 value of cosine of theta. All right. The last one, part B. Now we're going to talk about a reciprocal trig function being involved in an equation that has the other, the original trig function and its reciprocal. So remember, the reciprocal trig functions are cosecant, secant, and cotangent. And the reciprocal of cosecant, remember, is the sine. Reciprocal of the secant is the cosine. and the reciprocal of the cotangent is the tangent. And I've got this laid out down here for you. The cosecant is the reciprocal of the sine, secant reciprocal of the cosine, and the cotangent reciprocal of the tangent. Well, if you have a trig function and its reciprocal in the same equation, what you're going to do is you're going to replace, or you're going to substitute in, you're going to use these substitutions. So you're going to get the cosecant out and substitute in. So we'll write SUBST for substitution. Or if you have a secant of theta, you're going to take that out and you're going to substitute in the 1 over cosine. Or if you see you have a cotangent, you're going to do a substitution for cotangent in 1 over tangent. Well, what does this mean? Well, right here, you should notice how they want your answers. If you see 0 less than or equal to theta less than 2 pi, I want your answer in radians. So when you get all done solving it in degrees, convert it to radians. Up here, when you see this, I wanted your final answer in degrees. That's why we left it in degrees and we didn't convert it into radians. So just be careful on how it's being asked. So here we have a cosine and a reciprocal of the cosine in the same equation. So if you notice this could have been sine and cosecant, or it could have been tangent and cotangent. But if you have a regular trig function and its reciprocal, what you're going to do is take the secant out and substitute in 1 over cosine for it. So we're going to just drop this down as 2 cosine theta plus 1 is equal to 1 over the cosine of theta. That's the substitution. So this is actually like 2x plus 1 equals 1 over x. And if you have an equation that has a denominator, and this is called a fractional equation, you're going to have to multiply each term by the denominator, which is x, both sides. So you're going to multiply both sides of this equation by x. So this gets multiplied by x, 2x times x. The 1 gets multiplied by x, and this gets multiplied by x. X times 2x is 2x squared. 1 times x is x. And 1 over x times x, this is x over 1. So this x cancels out with this, and you're only left with a 1. And now you have an equation like we've done several times before. You have to subtract 1 from each side, set it equal to 0. Factor in, factor out the factors of -2 that add up to +1 are +2 and -1. So you got 2x plus 2 and 2x minus 1, all divided by 2. And then you can reduce the 2x plus 2 down into x plus 1 times 2x minus 1 is equal to 0. So then you have x equals -1 and x equals +1/2. But it's not x, it's cosine of theta. So we'll set up our t-table. We'll say cosine of theta is equal to -1 on one side, and cosine of theta is equal to 1/2 on the other side. Well, when sine and cosine is equal to either positive or -1 or 0, you take a look at the unit circle and you figure out which of these 4 points, these 4 major points on the unit circle, the x value is equal to -1. Well, over here we have -1, 0. So this is 180 degrees over here. Cosine of theta equals -1 at 180 degrees. And I want this converted into radians. 180 degrees is equal to pi radians. Over here you have a reference angle of 60. This is just like the problem above. And you have a quadrant 1 and quadrant 4 answer. The theta is 60 degrees, and 60 degrees converts into radians. 60 divided by 180, math frac, into pi over 3. In quadrant 4, the theta value is 300, and 300 over 180 math frac turns into 5 pi over 3. So this problem has 3 answers: pi over 3, 5 pi over 3, and just plain old pi. Now this next one, I would like you to shut the video off and do this one on your own. I want you to solve this in degrees, and you need to round to the nearest degree if necessary. Oh, up here, you didn't need to round it. I'm not sure why these instructions were up there, but this one it looks like you might have to. So in this problem, if you want to shut it off and try it yourself, that would be great. Otherwise, you can just watch me do this. The cotangent gets substituted in with a 1 over tangent. So we have tangent of theta drop down minus 5 is equal to 6 times 1 over tangent theta. Now this gets tricky because a lot of people like to multiply the numerator and the denominator by 6. Don't do that because this 6 is really 6 over 1. And when you multiply this, this becomes 6 over tangent of theta. So I'm just dropping the tangent of theta minus 5 down, and I'm going to multiply across. This 6 only goes to the numerator, not to the denominator. So there you have it simplified. And if you wanted to call this x, it's like x minus 5 is equal to 6 over x. Oops. And you're going to multiply everything by x. So this gets multiplied by x, this gets multiplied by x, this gets multiplied by x, and that just cancels out the denominator. X times x is x squared, 5 times x is 5x, and the x is canceled out, so that's equal to 6. And then you're going to subtract 6 from each side, and the factors of negative 6 that add up to negative 5 are minus 5 and plus 1. So you're going to just, I'm going to bring this up here. So you have x minus 6 times x plus 1 is equal to 0. X is equal to 6. X is equal to negative 1. But it's not x, it's tangent. So tangent of theta equals 6 on one side of the t-table, and the tangent of theta is equal to negative 1 on the other side. Well, now we need to get our calculators out, make sure our mode is set to degree mode, and do second tangent of 6. And we have a reference angle. It says round to the nearest degree, so this would be 81 degrees if you rounded that correctly. And that's our reference angle, 81 degrees. Well, tangent is positive in quadrants 1 and 3. So in quadrant 1, the theta value is the same thing as the reference angle. And in quadrant 3, the theta value is 180 plus 81, which is 261 degrees. So there's the two answers over here, 261 and 81. Over on the other side of the t-table, if you want to know about the reference angle, do second tangent of positive 1. Don't put a negative in to get a reference angle. Oops. And you get a reference angle of 45. So you'll remember reference angles are always positive. And tangent goes negative in quadrants 2 and 4. So the theta value is 180 minus 45, which is equal to 135 degrees. And in quadrant 4, the theta value is 360 minus 45 degrees, which is equal to 315 degrees. So you have 4 values of theta in this problem. And that's the end of my story. See you tomorrow. Stop.